Hello, today I'm going to talk Java HashMap internals. So Java HashMaps are very useful data structures in many implementations. The search time that is guaranteed by hash table is almost constant. So that is the most important property of HashMaps. For example, the access time for tree maps is logarithmic. So it's worse. Of course, tree map has other advantages over the hash table, but if you want to have a extremely fast search time when looking for values that are stored under some key objects, then you should choose HashMap. All right. So. I will try to describe example of internal implementation, and you will see that this internal implementation will affect the way that you should implement your objects that you will be used as key values for storing your value objects. All right, so let's consider a class K, which we'll be using as a key. So instances of class K we will be using as a keys for our HashMap. And here we have a HashMap. Yeah? This is our internal body of HashMap. So HashMap internal is using a hash table. For now, let's declare a capacity of it like 0, 1, 2, 3, 4, 5, 6, 7, 8 elements. Actually 9 elements. All right. So this is the hash table, and we see that this is just indexed table. We call those entries buckets. Yeah. So every time we want to put some key value pair into the hash map, the index of hash table is calculated, and we store under some bucket this key value entry. All right, so let's suppose we have a K1 instance of K class along with V value that we would like to store in this hash map. So for this key, our internal implementation of HashMap calculated index 3. How that happened? So in Java, HashMap is calling from K1 method hashcode, yeah, which returns us some number, yeah, and this number is then used to calculate hash table entry, yeah. So normally HashMap implementation will use hashcode result in another function that is calculating a bucket entry. So after calculating hashcode, we got index 3 from hash table, and here we store a value V along with key 1 as an entry. Yeah. So let's say for another object K2 and some value V, our HashMap calculated hash table entry at index 0. So here we store K2 and value. Yeah. So let's suppose we have another object which we want to use as a key, K3. Yeah. And K3 we want to put at some index, and the important thing is that K3, because of some implementation of hashcode method in K class return us the same value like hashcode for K1. And then our HashMap will try to put K3 along with value under the bucket 3. So what will happen? Hash table from now will store K3 and some value V under bucket 3, but in a linked list. So from that point, K1 value entry will point using a pointer which is called next, will point to the K3 value. Yeah. So if we have many objects that are different in terms of equals method, then and they return us the same hash code, probably our hash table will degenerate, and we have a much worse efficiency, much worse performance of the structure. So instead of almost constant access time to object, we might end up with square complexity, square time, because if someone wants to retrieve K3 object from the hash table, of course the bucket number will be calculated immediately. However, then our HashMap should iterate over a collection that is stored in a bucket and try to find proper key value pair using equals method, and it will try to compare each key from this list, yeah, with the key that is used to retrieve some object. So that's the problem when you want to when you implement where you are implementing hashcode. You should take care about the returning values for different objects in terms of equals method. But it's not the worst problem that might happen. The biggest mistake is when you have two objects. Let's say K1 we have here, and here we have K1 prime that we want to store in a hash table along with some value, and K1 is equals with K1 prime in terms of equal method. However, both objects returns different values using hashcode when you call hashcode on them. So for K1 prime, our HashMap after calculating hashcode will suggest bucket number 7, yeah? And here we store K1 prime along with V value. And now we have the same objects K1 and K1 prime, but on different buckets. And that might lead our program to memory leak. And apart from memory leak, of course, our business logic might stop to work. Because we already have element in our HashMap, yeah? So that's the biggest mistake when it comes to equals and hashcode contract. So the contract between equals and hashcode is as following. This is very important when you want to use your objects as the keys to HashMap. If object 1 is equals with object 2, they are instances of some class, yeah? Then O1 hashcode must be exactly the same like O2 hashcode. This is the most important part of hashcode equals contract. Yeah, this is a must-have element of this contract. Of course, if you implement hashcode that is returning always the same value for any instance of some class, it's not a problem if you have very little of elements in HashMap. However, it's another thing that you should take care. You should distribute hashcode values proportionally, and they should be different for different objects in terms of equals method. All right, so that's the thing that is that impacts performance of hash tables, and this you should always think about this contract when you want to store your key class. Use key classes as an access object to hash maps. Okay, thank you.